For years, the law of AI progress was simple. To make a system smarter, you had to make it bigger. The only way forward was the brute force construction of massive trillion-parameter models. Running those systems requires warehouses full of dense custom silicon. Training a single base model now demands a physical and financial scale that very few organizations on Earth can actually afford. But that era is hitting a wall. The industry is realizing that simply adding more raw size and more data is no longer yielding the same massive jumps in intelligence we saw just a year ago. The race for sheer scale has reached a ceiling. To keep the technology moving forward, researchers have to find a way to increase capability without making the models any larger. Ji Teng, the CEO of the Chinese lab Z.AI, recently announced what he calls the death of params. He argues that the internal dials determining a model's raw size are no longer the primary driver of intelligence. His lab proved this by shipping GLM 5.3. It achieved sharp gains in coding and logic, while using the exact same 743 billion parameter base as the previous version. They didn't add a single parameter to the model's core. Instead of building a bigger brain, they put the existing one through intense reinforcement learning in a simulated environment. By learning from its mistakes across thousands of trials, the model learned to execute complex chains of logic without losing the thread or needing more memory. The industry is moving away from the massive one-time cost of building giant models. The new currency of AI intelligence is repeatable, focused practice on realistic tasks. But a smart model is only useful if it can respond in real time. For AI agents checking files or calling tools dozens of times a minute, any delay in the output makes the tool feel broken. Liquid AI tackled this latency problem with a software solution called DeepSeek. It uses a technique known as speculative decoding to speed up a model's responses for free. In this setup, a tiny 300 million parameter helper model rapidly guesses the next several words in a sentence. The main model just checks those guesses, like an editor quickly approving a fast typist's work. The results are identical to what the model would have said anyway, just delivered 3 times faster. On server-grade chips, the output jumped from 326 words per second to a staggering 1,000. These performance gains come from mathematical tricks performed after the model is built. High-speed output is becoming a toggleable software setting rather than a feature you have to buy with more hardware. Once models are fast and well-practiced, they need to be integrated. Developers require a way to cleanly connect these brains to the diverse software tools they use to write code or manage data. This demand pushed DeepSeek Harness to become the fastest-growing project in GitHub's history. It pulled in 92,000 stars in just 28 hours, roughly 80 times the pace of the previous record holder. It's built on a philosophy of spatio-temporal composability. Essentially, every single part of the AI agent, the model connector, the tools, and even the core logic loop, is a hot swappable plugin you can replace with a single line of code. This design has split the developer community. Fans see a future of ultimate flexibility, but skeptics worry that turning every single function into a plugin creates a level of complexity and fragility that most teams don't actually need. Regardless of the debate, the infrastructure of AI is officially moving away from rigid, monolithic systems and toward highly granular, customizable ecosystems. These efficiencies are already showing up in the real economy. The software company Stamply recently used AI assistants to coordinate a major product launch, connecting their product context and messaging into a single automated system. They condensed that work by 68%. A production cycle that would have taken humans 243 hours was completed in just 77, while keeping human experts in charge of the final approval. But extreme optimization introduces a hidden fragility. As models get smaller and more focused, they enter a jagged frontier, where their reliability depends entirely on the specific way a task is framed. A recent study found that simply renaming a variable or adding unused code to a project caused the success rate of top coding agents to drop by nearly 7 percentage points. The AI's logic was functionally identical, but the cosmetic changes caused the system to fracture. As AI becomes faster and more integrated, its failures are shifting. They are moving from obvious, loud errors to invisible, systemic liabilities that only appear when the context changes. Anticipating this total integration of AI into society, OpenAI launched a new strategic futures team. Their mission is to plan how laws and personal rights must be reshaped as these systems become more powerful. Their first report bypassed standard worries about rogue machines. Instead, it focused on the historical risk of tyranny, arguing that we must prevent any one group from accumulating too much control over the coming infrastructure. They identified the concentration of power as the single largest long-term risk, warning about a future where a handful of companies or governments control the most capable models. This risk persists even as tools become modular. While anyone can now build a plugin, the base models and the core architectural standards remain proprietary. Whoever sets those standards ultimately dictates the boundaries of what an AI agent is allowed to do. The end of the scale era didn't necessarily democratize the underlying technology. By weaving their proprietary standards into the foundation of these modular tools, the largest labs have ensured that as AI becomes smaller and more indispensable, the control over its core logic remains centralized.